Ladies and gentlemen, welcome to our mathematics revision class, and in this mathematics we are just going to look at Math 1120 2023 exam questions, and this was prepared by the University of Zambia Department of Mathematics and Statistics. Okay, for new members, this is Dr. Possibility from Excel Academy. Let me quickly look at question 5, which has 3 parts, A, B, and C. However, due to time, I'm just going to solve A and B, and C, because it has calculus, I'll do it on its own. I'll start with A, which is saying, find the domain of a function f of x is equal to 1 over square root 1 minus x. Ladies and gentlemen, this is free mark, but this function has been split more like into two sections. This function has been split more like into two sections. There is one, this part, which is square root 1 minus x. This part is forming the radical function. This part is forming a radical function, and this other guy here, everything there, it's coming up to a rational function. It's coming up to rational function. So this function is depending on both, such that you don't need to have a negative and you inside the root, and you also don't need to have a 0 down there. So when finding a radical function, the domain of a radical function, no matter what we do, is 1 minus x should be greater than or equal to what? 0. So this is what we do. But because this guy is a rational function, it doesn't want a 0. So that simply means that we are not going to go this way, but we are going to go the way I'm about to explain. So we have f of x, which is simply equal to 1 over x square root x minus 1. So in this case, what you are going to do, you are just going to get what is inside there. You say x minus 1, you say domain, then x minus 1 should be greater than what? 0. X minus 1 should be greater than what? 0. Is it x minus 1? No, it is 1 minus x. I've written a wrong expression here. So it is 1 minus x and not x minus 1. So we have 1 over square root 1 minus x. So that's what we simply have. So in that case, what we are going to do, we are just going to get what is inside there. And if you look what is inside there, it is 1 minus x should be greater than what? 0. So 1 will go to the other side, so you're going to have negative x should be greater than negative 1. Then after you do that, you're going to divide throughout by negative 1, divide throughout by negative 1. Automatically that and that will cancel. So in such a case, you are going to have x is less than 1. Why are we putting less than 1? Because this guy you have divided throughout by a negative. Therefore, if you look at the domain of this particular function, the domain, if you look at this particular function, it is this same guy, but you can also write it in set beta notation, which or in set interval, whereby you're going to say negative infinity comma 1, negative infinity comma 1. So that will be your what? That will be your solution. In a case you are asked to to draw this using a number line. I've already found the answer, which is this one or that one. Both of them are correct, but I just want to explain something. In a case you are asked to do this question on a number line, or to represent your answer on your number line, this is how it's going to look like. So you're going to have negative infinity and then positive infinity there, then 0 to demarcate what the negatives and the positive. So on a number line, this will be represented as 1 there, and then it will be open bracket, and this guy will go towards the left hand side, and this is simply the domain we are looking for. But all in all, you would have ended there. This is set builder notation. This is set builder notation. Okay, this is set builder notation, and then this one is set intervals. So this one is for intervals, and then this other one is number line. So it depends with how they have set the question. So in my case, I've told you all the three concepts. With that being said, I would allow questions if there are any questions. If no questions, Florence, you can unmute yourself and say no question. Any question, ladies and gentlemen? Yes, Miriam.
I have a question.
Yes.
On the side there, why are you saying to say X to get from 1 on the account?
Because we have divided by a negative.
Okay. So in the case of where it's then divided by a negative, you just carry the sign of that.
Yes.
Thank you.
You're welcome. Okay. Haggai, yes, what's your question?
The one on top, is it not having any effect on the domain?
No, it doesn't have.
Alright.
Okay. So please watch my tutorial classes on radical functions. You can find it on our YouTube channel. I have already explained on how to sketch the graphs, how to find the domain, and also how to find the range. So let me quickly look at this part, which is inequalities. So here you have modulus of 1 minus x over 1 plus x, and then you have less than or equal to 1. I think this has been explained at some point. So what you're going to do, you're going to say 1 minus x over 1 plus x is less than or equal to 1, or this same guy can be written as 1 minus x over 1 plus x is greater than or equal to negative 1. So when you have a modulus like that, you have to split this equation or inequality into two. You have to split this inequality into two. One of it has to go the way it is, and it has to be positive. The other one, it has to go like that, and then the sign will change and you put a negative on the other side. So with that being done, you're just going to get this one there. I'll work on this one first, which is 1 minus x over 1 plus x, then less than or equal to 1. 1 will go to the other side, so you're going to have 1 minus x over 1 plus x is less than or equal to 1 will go to the other side, so it's going to be 1 minus x over 1 plus x minus 1 over less than or equal to 0. Do not cross multiply. Do not cross multiply. I think I solved one of the questions and I told you that rule. So from there, common denominator, it is 1 plus x. Then 1 plus x into 1 plus x, it is 1. 1 times that, it is 1 minus x. Then the negative there, most people they make mistakes on that. So you're going to carry it the way it is with a negative. So you put negative 1 open bracket, 1 into that, it's simply that, which is 1 plus x, and then it is less than or equal to 0. Less than or equal to 0. Then from there you say 1 minus x will be maintained. Then that times that, it's negative 1, and then negative 1 times x, it is negative x over 1 plus x, and then is less than or equal to 0. If you work out those guys, when you work out these guys here, you're going to find that the numerator, this guy and that guy will go, and the topmost will be negative 2x over 1 plus x is less than or equal to 0. So this is what you are going to have. So when you have that, your next point is to find the critical point. Okay, is to find the critical point for this particular equation. So how to find the critical point for that inequality? You're going to say negative 2x is equal to 0 over negative 2 over negative 2, x is simply equal to 0. And you're going to get that other one, 1 plus x, you equate it to 0, so x is equal to negative 1. So these are the two critical points in that particular equation. So those are the two critical points. So when you find the critical point, you're going to find the solution set for this guy. Okay, so I'll write my solution once again. Remember, we have the CPs. The first one is x is equal to 0 and the x is equal to negative 1. So I'll draw my table like we did to that other question. So I'll draw my table like that. I'll draw my table. Then here it's going to have that part. Then this side I'll have negative 2x. Then the other one, it will be 1 plus x. Okay, and then I'll do that. Then I'll have the first part and I'm going to have the other part. Okay, then once I do that, you need to understand, I need to compare the size. So this one is small, that one is big, so 0 will be there, negative 1 will be there. So once I do that, I can plug in what is inside. So x should be less than negative 1, then there negative 1, then x, then what, then 0, then x should be greater than 0. Upon doing that, if you remember very well, the normal equation is something that is negative 2x over 1 plus x, according to what we solved on top there, for this guy here. Once I do that, I'll look for a number which is less than negative 1. I'll look for a number which is less than -1. So if I look for a number which is less than -1, I'll get -2. This one will be positive. I'll get -2. This one will be negative. A number in between -1 and 0, it's -half. So there it will be positive. There it will surely be positive. There it will be positive also. I get a number which is greater than 0. Let's say I get a 1. 1, it will be negative. 1 there, it will be positive. So once I have those guys, if I say positive times negative, it's negative. Positive times positive, it's positive. And negative times positive, it's negative. So from that, I'll go back to my equation. My equation is this one. It has a less than there. Okay, so let me rewrite that for easy understanding. It is -2x over x plus 1, or 1 plus x is the same thing, and then that. So if you look at that, the one which is on top here is telling you that we want the negative. So you get that as your answer, that also as your answer. So for the first part, you have this guy which is x and that, and also you have x is greater than 0. So before you put an equal to, there is this equal to. You need to see if it is capable of suiting the domain. So when you get -1 and put it there, if you put -1 and put it there, it's going to be 0 down. So since it's going to be 0 down, you don't have to put an equal to on this one. But if you put a 0 there on top, it will be 0 for the numerator, which is not a problem. So you're going to put a 0 on an equal to on a 0, but not on a -1. Reason is that when you put on a -1, that question will become undefined. Okay, because that's a rational function or rational expression. That's why we are not putting an equal to on -1. But we are putting an equal to on 0 because we understand that when the numerator is 0, it won't affect anything, because 0 divided by anything, it is simply 0. So that's why we are having such a solution. So the first solution will simply mean that I'll express it in the set notation. So this guy is the same as open -∞, -1, and then this one will be simply block bracket 0, +∞, open bracket. So for the first guy, it is simply open -∞, -1, open, and then union. You're going to have a block bracket. This is a block bracket. Take note of that. This is a block bracket 0, ∞. So this is the first solution. Once you're done with the first solution, you have to go back and do the other set of questions. So I'll go back and pick up the other set, which is this set there. This set is as follows. It is 1 minus x over x plus 1, and this is greater than or equal to a -1. So that's the other guy here. So once we do that, once we have that information, we can simply solve it in an easy way, whereby common this guy go to the other side, so it's going to be 1 minus x over x plus 1, then plus 1 is greater than or equal to 0. When you have that, you're going to find that common denominator, it is x plus 1, and then this into that, it will be 1 minus x, then that this one into that, it's that, automatically 1 times everything there, it will be that, and then it's c greater than or equal to 0. With this information, ladies and gentlemen, you find that x and x, they will go, so you have 2 over x plus 1. 2 over x plus 1 is greater than or equal to 0. I'll move on and look at the other parts. So what I'll do is I will erase this section, and also I'll keep this other section due to space. I'll erase this section or that one, but okay, let me do this. So after we find this, we can look for the critical points. So remember, we have 2 over x plus 1 is greater than or equal to 0. So the critical point is only x plus 1. So the critical point is only x plus 1 is equal to 0. So x is equal to what? Negative 1. Okay. So from here, what you have to do, is as follows. So you can use the table. Now this time around, the table won't look the way it always look, because it is only having one single critical point. So this is what you're going to do. You're going to write like that, then you're going to put that, and then you're going to demarcate there. Once you demarcate, you're going to utilize your only critical point, which is negative 1. Then here it will be a 2, there it will be what? There it will be a x plus 1. Then there will be that demarcation like that, and down there automatically is 2x plus 1. So in this first box, it will follow the way it is. X should be less than negative 1, and then this one, x should be greater than negative 1. So if you put anything on 2, it will still be positive. It is going to be a positive. Then if you put let's say a negative 2 there, this will be negative, but when you get a 0 there, this will be positive. So negative times negative, it's giving you negative. Positive times positive, it's giving you what? Positive. What answers are we looking for? If you go and check from the arrow there, it's telling you that we want the positive. Therefore, the solution here is simply equal to open bracket negative 1 comma what? Positive infinity. You end like that. Now you have two solution sets. Remember, we had the first solution, which was this one here. Okay, we had this solution, which is open bracket recall. So I'll write recall there. Recall that we had the negative infinity comma negative 1, and then open bracket union, you also had block bracket 0 comma infinity open bracket. So what you have to do now is to find the intersection of the two sets. Find the intersection, okay? Find the intersection of the two sets. So when you are looking for the intersection, in that case you can use the number line. So you're going to visit your number line now. So 0 will be there, negative infinity there, positive infinity there. Once you do that, what you are going to indicate is for this one first. So negative 1, it's going open, it's open and going toward negative infinity. Then 0, it is closed, it is blocked like that, okay? It is blocked, and it being blocked, it is going this other side. That's why it is 6 marks. It is having a procedure. All these what I'm doing are the method marks, and everyone is supposed to reach them. So from there you also sketch the other guy. So I've sketched this guy in red. Now I'm sketching this guy. So this guy is negative infinity or negative 1, okay, open up to positive infinity, which is this side. So the intersection set between the two guys, is simply this region which I have colored. So this is the intersection set for these guys, of which we know that 0 is in both sets. 0 is in both sets. So in such a case, what you are now going to do is to write your solution set. Therefore, what are we looking for? Therefore, the solution set is simply equal to this part, which is the block bracket 0 comma positive infinity open bracket. So this was the final answer for this particular question, and the topic is inequalities. Okay, do we have any questions, ladies and gentlemen, so that I can move on? Alright, since we don't have a question, I'll go to my second question, which is my last question. This is a very easy question. So what I'll do, okay,
Sir, sorry to disturb you.
Yes, you can ask.
We're on the second book.
Yes.
Yeah. Where did you get the 2 plus 1? How did that come about?
Which 2 plus 1?
The one that's in the second box, for the one that only had one solution, one critical point. So
yes.
Yes. Where did that 2 and the 2 plus 1? How did you?
I can't see a 2 plus 1.
So she's talking about the x plus 1. It's looking like 2.
Oh, it is x plus 1. My handwriting.
Oh, so the top one is x.
The top one is
No,
2.
the top is 2.
The top one is.
This 2 is coming from
I
that
don't
2.
understand how.
This x plus 1 is coming from there.
Oh, okay.
You now understand it?
So to get that, yes. So now to get that positive sign,
Okay, you're going to
you are replacing.
okay for this one.
When you
For this one, what you're going to do is, for you to know these signs, you're going to get a number which is less than -1, like this sign is saying less than. So you're going to put it here. Now here you don't have an x. That means that it will just be positive, because it's a constant number. It will just be positive. Then for a -2, when you put it here, -2 plus 1, it's -1, which is negative. Then if you get a number greater than -1, you get a 2. You put 2 there, it will still be positive. 2 there, it will be 3. 3 is positive. That's why we are getting the positive there. And then for the down signs, for the signs which are down, you are just going to multiply positive times negative. It's the negative which is down there, and then positive times positive, it will give you a positive. Is that okay now? Is it okay?
Yes, I understand.
All right, let's move on and look at the next
Yes,
question.
I understand. Thank you.
You're welcome. Let's move on and look at the next simple question. The next simple question, simplest in today's class. So for the secret of this, the secret for this question, check out the tutorial class. Check out the tutorial class on domain and graphs of radical functions. Go and check out these classes. There are about 2 or 3 of them. I'll send the links if I'll check out. So you have f of x is equal to square root x minus 1, square root x minus 1, and then minus 1. So here, guys, the first thing you need to do is to find the domain. So the first thing you need to do is find the domain. Okay, so the first thing is you find the domain, and the domain you are going to get what is inside, which is x minus 1 should be greater than or equal to 0. So x will simply be greater than or equal to 1. Okay, so the graph of just the graph, okay, I'm teaching, that's why I'm going to write this step. The graph of let's say y is equal to square root x minus 1, the graph will look like this. It's simple, very simple. Okay, if you check, you should check out the classes. So you have the y-axis, you have the x-axis, isn't it? You have the y-axis and also the x-axis. So for the graph, it will start from 1. Okay, it will start from 1, then it will go up like that. It's this guy, it only produces positives. Okay, it only produces positive, so it will go like that. Okay, it will go like that. So this is the graph of this guy there. Okay, but it's not the graph of the answer. This is the graph of that guy here. So once you know how to sketch the graph, you're now going to check out this -1 there. You're going to check out the -1. So the graph of the equation, which is f of x is equal to square root x minus 1 minus 1. It depends on this graph, such that you are just going to move down. the same value which is -1 there, we are just going to move it down there. Okay, so this is how it's going to look like. So you have the y-axis, you also have the x-axis. Okay, those are the axes, and then what you are going to put is this. You are going to put -1. This -1 here, if this was -2, you put -2. If this was 2, you go up. If this was 2, you are going to go up, but it has to look like that. So you are going to put -1 there, and you're also going to put a 1 there. Okay, you're going to put a -1 and also a 1 there. So this is the one, right? So your graph is starting from here. Your graph is starting from here, and then it's close, it's going like that. Okay, this is how it's going. So it's going like that. So this is how a graph is, but you haven't answered the question completely. So how can you answer the question completely? You're going to look for the what? You're going to look for the x-intercept. You're going to look for the x-intercept. So for you to look for the x-intercept, I'll come back. So you're going to say f of x is equal to square root x minus 1 minus 1. So you're going to make this 0. So 0 is equal to square root x minus 1 minus 1. This will go to the other side. So it's going to be square root x minus 1 is equal to what? 1 when this goes to the other side. You introduce a squared. So x minus 1 is equal to 1, right? This will go to the other side. X is equal to 2. Okay, so this x is equal to 2. It is where now this graph is cutting the axis. So we are going to put a 2 there. So these are the 3 coordinates that are important when writing out this graph. So this one, the 1 there, which is making part of the domain, the -1 for the range, and the 2 for the y-intercept, where y is equal to 0. So after you do that, not y-intercept, x-intercept. After you do that, you can now look for the range. If you check, there was a question we solved from this same paper which had a 1 mark, and that means that your answer should simply come from the what? From the graph. So from this graph, you find that it is starting from -1 going up, of which this side it is what? This side it is positive infinity. This is positive infinity, and this side is negative infinity. So the range is within this side. That's why you can see this graph going like that. So the range will be block brackets -1 comma infinity, and then close bracket. So this is how easily you are supposed to move. Every movement I've made except this part here, they deserve a mark, and you can't find the answer without making all the steps I've made on this question. So ladies and gentlemen, this is what I had for you today. But if you have a question, in case you have a question, you are free to WhatsApp me. And for those who are in class, if you have a question, you can ask right now.